Root mean square value of alternating EMF. My dear student, in the previous video we have studied how can we calculate root mean square value of alternating current. So the same steps will be followed as in the previous topic, but here now current I will be replaced by E by R. Okay, so that will make your derivation easy. So if we write the definition, the same wording, only the word current will be replaced by EMF and heat will remain same. So we can define that RMS value of alternating EMF is that value of voltage, which would generate same amount of heat as is generated by the voltage in the same resistance, AC voltage in the same resistance in the same time. So exactly same definition, only the current is replaced by voltage. So now the first step was DH. DH in the previous topic we have taken I square R dt, but in this case we will write as E by R, E square by R square into R dt. Now we know that E is equal to E naught sine of omega t. So we give it number 1 and we cut this by this, we get E square by R into dt. So this is the small amount of heat generated. Now the total amount of heat generated during the whole cycle will be calculated as by integrating dH, which is equal to H, which is equal to 0 to T E square by R into dt. Okay, now in this case E square by R is constant, so we take it out, E square by R, right? And we left with, okay, no, E square we will put the value, R is constant only, since E is a varying value of E naught sine omega t. So we'll write here E naught square sine square omega t dt. So this E naught square is taken out. E naught square, which is the constant value, E naught square is taken out, and now we can write it as this is sine square omega t dt. Now again see, same expression has been obtained, integration of sine square omega t from 0 to t. Now again writing as E naught square by R. Now sine square omega t can be written as 1 minus cos of 2 omega t divided by 2 into dt. So this 2 is also taken out. So what we will do here, E naught square by 2R, this becomes integration of dt 0 to t minus cos, integration of cos of 2 omega t dt 0 to t. Okay, so now solving it, this is E naught square by 2R, this is t minus 0, upper limit minus lower limit, and this is cos is sine of 2 omega t. Okay, t minus sine of 2 omega 0 upon 2. Okay, I just put the limits directly. Now in this case this omega will be this is 2 pi by t, right? So sine 4 pi is 0, sine 0 is 0, so this whole term becomes equal to 0. So I will just rub it and we are left with the term this. So we'll write here E naught square by 2R into t, right? So we get the amount of heat produced as H is equal to E naught square by 2R into t. Okay, exactly same in the previous topic we have assumed that if IV is the virtual value of current, now we will assume that if EV is the virtual value or RMS value of EMF, virtual or RMS value of EMF, in that case this H is equal to EV square by 2R into t. So comparing these two, I will write here this E naught square by 2R into t. Okay, no, here it will not be 2, actually H will write here IV square RT na, so IV, instead of IV will put EV by R whole square into RT. So that will be EV square by R into T. So it will be EV square by R into T. Correct hai. Here E naught square by R. Okay. So T to T cancel out. R to R cancel out. We'll left with EV square is equal to E naught square by 2. Or we can say EV is equal to E naught by root 2, which is equal to 0.707 of E naught. It means the virtual value of EMF is 0.707 times the maximum value of EMF. Okay, so this is how we have done the derivation of root mean square value of alternating EMF.